Good morning.
Good morning, dear.
Good morning.
Good morning, dear. Let's see.
Good morning.
Good morning.
Good morning.
Morning.
Good morning, dear. Okay, girls. So, any questions so far? No. Any questions about pulse duration, spatial pulse length, its relationships? The calculation of it? No? So you guys are good on those things? Okay, girls. So the next is going to be okay, what we call is okay, bit pulse repetition. Period. Now, if you just break this up, it pretty much okay, it's going to tell us what it actually is. So this was a pulse. Was a pulse? That was meaning it's okay. It's okay. It's okay. A number of cycles that will make up a pulse. Clear? So we can say it's okay. We have a pulse. Period mainly mean that this is something that's going to as okay be measured in time. And repetition is we can say that how it is repeated. So a pulse repetition period actually is okay accounts for the time. If we said okay, this was one pulse, and okay, as we have another pulse, then this here becomes just okay the time after which okay as a pulse is being repeated. Clear? Okay, that's what we as okay what we call a pulse repetition period. And you mainly as okay we'll see that okay as from time to time yes okay whenever we talk of pulse repetition period is okay is going to be abbreviated as a PRP. Not something. Okay. Welcome there. Okay, so what is the pulse repetition period? We can mainly say, okay, it is the period after which, okay, as a pulse is being repeated. Okay, now if we look at this pulse repetition period here, because, okay, it is going to be, as okay, we may say, okay, or the definition is from the beginning of one pulse. Right, okay. And we can say, it's going to be, okay, the time. Okay, because it's a period. So it's going to be, okay, the time from the beginning of one pulse to the beginning of another pulse. Or you can say another, it's going to be, okay, more correct, the next pulse. That is going to be, okay, what we call a pulse repetition period, or a PRP. So we can say it this way: if this was one pulse, and okay, yes, you say, okay, that this area was one pulse. Okay, the PRP is mainly, as okay, going to be, as okay, the time from the beginning of this pulse to the beginning of this pulse. This whole time here, is okay, is going to be referred to as the PRP, or the time after which, yes, okay, a pulse is being repeated. Now, when we look at it, this PRP here is actually, okay, going to be made up of two components. We have, okay, as what we just, okay, yesterday called pulse duration, right? We also call this time here as, okay, the talking time or the on time. And then it has this period of silence here. Clear? It has this period of silence, which we may as, okay, call the off time, or we also call it the listening time. Okay, so the on time and listening time, talking time and listening time, on time and off time together makes up the pulse repetition period. Did that make sense? After which we can mainly say, okay, we just have another pulse with its own off time as well. After which, okay, as there would have been, okay, as we see, another pulse. So then this here is, okay, would become this whole here is, okay, that becomes just, okay, the PRP. Likewise, this whole thing here is, okay, became the PRP, but it's actually made up of the on time and off time. On time and off time together makes up your pulse repetition period. Is that clear? Now, girls, please do not confuse this with the pulse duration. Okay, a lot of students just, okay, end up as, okay, confusing this definition here with pulse duration. Okay, mainly because, okay, now both of them were as, okay, the time. Okay, but when we say pulse duration, that was going to be as, okay, because it's, okay, from the beginning of the pulse. There we can say it's okay would be here. Okay, which also is okay is going to is okay be the beginning of a pulse. But it only as okay goes to the, we can say it's okay, end of the pulse, which was this. Whereas your PRP was the time from the beginning of one pulse to the beginning of the next pulse. Where we said, okay, this was one pulse. This was okay as another pulse. So the time from the beginning of this pulse here to the beginning of this pulse, that becomes your pulse repetition period. Whereas you say it's okay, the time from the beginning of one pulse, of a pulse, to the end of that pulse, that is what we call the pulse duration. Okay, and context is okay, yes, okay. The pulse repetition period that could also be referred to as the talking time or on time, because the other part that made up your pulse repetition period was going to be, yes, okay, I refer to as the off time or the listening time. Is that clear? So that's the difference between, yes, okay, the two. Both of them, as okay, are measured in terms of time, but one is only as okay from the beginning of a pulse to the beginning to the end of the pulse. That becomes your pulse duration. Whereas the pulse repetition period goes from, it's okay, from beginning of one pulse to the beginning of the next pulse. This whole time here, if we measure this in terms of time, that becomes the pulse repetition period. Did you ladies get that? Okay. So yes, okay, a lot of students still confuse the two. The only thing that they have in common is that, okay, as they are measured in terms of time. Clear? So that mainly, as okay, gives us, as okay, what is the next thing about, as okay, a pulse repetition period? It is going to be the unit. Okay, now when you see the word period, it should directly, as okay, hit your mind, okay, as this is going to be something that talks about time. Okay, so when you're referring to anything in terms of time, it's going to be measured in time. It's going to be, as okay, expressed with a unit of time. Clear? That's why, as okay, units are important. Because as okay, you say two, that's just a number. But once that's okay, you put a unit onto it, you specify to what. Clear? Okay. Not only as okay, specify as okay the worth of the number, but also as okay what that number is okay represents. Clear? Is that clear, girls?
Yes.
Okay. Now the typical value. Now, well, okay, there really isn't going to be as okay typical value, and we're going to just okay talk about that in just a little bit. Okay, so don't worry about as okay what the typical value talks about here. Okay, what is going to become important is okay as far as we say the typical value of a PRP is going to as okay be the ratios or the relationship between on time and off time, and we'll talk about that in just a little bit. But it is going to be as okay important to know as okay what determines it. What determines your pulse repetition period? Clear? Okay. So that's okay. I guess that's okay. Pulse repetition period is determined by the source. Clear? It's going to, yes, okay, be determined by the source. Now, ladies, in the PRP, as we said, sorry, that's not PPP. In the pulse repetition period, we could actually say it's okay that was actually it's okay made up of 2 periods, right? Okay. Okay, because that's okay, that was mainly going to be the sum of the on time and off time. And or we could also say that's okay, we're going to likewise, that's okay, be the sum of the talking time and the listening time. So let's a moment, let's go. Right, okay. Or if you don't like to use the word on time or off on time or talking time, you can say that's okay. The pulse duration. Plus that's okay, any of these two here. Is that clear? Okay, so if you said, okay, yes, that we had a pulse repetition period. I was going to be made up of, okay, that's when we put together, yes, okay, the on time. And the off time, after which, yes, okay, because that's okay, we'll have, okay, that's another pulse here. And what we mainly said was, okay, yes, your pulse repetition period. At least it's okay, that's on time here. Or the pulse duration, it's okay, also it's okay, was determined by the source. Now, what I said yesterday, so this whole, yes, okay, duration from here to here, is okay, that's what we call the pulse repetition period. Now, what I said yesterday was that, well, okay, as we need ultrasound to, yes, okay, be produced in pulses and not continuous waves. Right, okay. Why? Because, well, like we said, that the pulse doesn't mean it's okay, just a number of cycles together followed by us, okay, a period of silence. And what actually happens in this period of silence on and off time, that is actually it's okay where this pulse here, because it's okay that the pulse actually is going to, it's okay, travel to a certain depth and come back. After which we can see it's okay, another pulse is going to be produced, which mainly is okay, is going to travel to a certain depth and reflect back. Okay. Did that make sense? So we can mainly say, okay, that's the time from as okay, this pulse being produced to this pulse being produced, that is going to be as okay, your pulse repetition period. Where you had, okay, the on time, in which, okay, as the pulse is being produced, where the off time mainly as okay, is going to, as okay, just be responsible for the pulse traveling to a certain depth and return back. After which, okay, as another pulse is going to be sent out. Did you girls get that? Just give me a second, girls. Or ladies. Did you girls get that? Okay. So that mainly is okay. That mainly is okay. Take us to yes, okay. We can say it's okay. One and okay. Yes. The next point is Medina. So go. Is the PRP adjustable? And what we mean by adjustable, which means it's going to mean yes, okay. Can we change it? The answer is yes. The answer is that okay, yes, we can change the PRP, which mainly mean that okay, yes, we can change the time between yes, okay, the beginning of one pulse to the beginning of the next pulse. Okay, and we can say, okay, here this might be yes, okay, the PRP or our pulse, which can be changed. Like this. I'm sorry. Okay, where this now is our PRP. The next question then just is, how do we can say it's okay, adjust the PRP? And that is mainly it's okay by adjusting the depth of image. Okay. So what we mainly can say here is that okay, as in these two examples, if we say okay, this is A, this is B. Okay. It's the same transducer, which means as okay, produce, we can say as okay, pulses with the same pulse duration or spatial pulse length. But in one case, that's okay. Is it going to be as okay? That pulse travel to a shallow depth and return back. Whereas, okay, in this case, it's okay. The pulse travel to a greater depth and come back. Is that clear? Okay. So here mainly because, just give me a second, guys. So, sorry, boss. The system produces a pulse, but mainly it's okay because it's going to it's okay travel to shallower depth and come back. What is it we need? lesser time. Whereas, okay, as here we produce a pulse that is going to just, okay, go to a greater depth. And that will mainly as, okay, need more time. Okay. So this more time here is, okay, that's going to be, okay, be a greater pulse repetition period, whereas, okay, here, this less time here is going to be as, okay, a shorter pulse repetition period. Okay. Because we don't really want as, okay, one pulse to get interfered by another pulse. One pulse getting interfered by another pulse. That's why as, okay, the system mainly as, okay, is going to work based on the concept saying, well, okay, yes, we produce one pulse. It is set to, yes, okay, travel a certain depth and come back. Only then is it that, okay, as the system will say, well, okay, this is going to, yes, okay, be the time where, yes, okay, we produce another pulse that then is going to, yes, okay, travel its depth and come back. Meaning, yes, okay, producing, yes, okay, a third pulse that is going to, yes, okay, travel its distance and return back. Clear. So you can mainly say, okay, the time that it takes from this pulse here to be produced by the system to this pulse here. The time span between the production of pulse 1 and pulse 2 and pulse 3 and pulse 4. So that time span is going to be called the pulse repetition period. Okay. And that is going to, yes, okay, now the only way that, or the way by which we adjust it is mainly as, okay, by adjusting the depth. And if you look here, it's okay, by adjusting the depth, what is that we actually is, okay, change. The only thing that is changed is going to be as, okay, the off time. As I said yesterday, that the off time or the listening time, that is actually going to be the time that the pulse will need to travel to a certain depth and return back. After which, okay, as we can say is, okay, and other pulse will be produced. So by changing the depth, whether we as, okay, increase the depth or decrease the depth, we actually as, okay, either increase the off time or decrease the off time. Mainly as, okay, to give the pulse more or time, as, okay, more time or lesser time to, as, okay, travel to a greater or lesser distance. Did that make sense? Now the question then just arises, so what is going to, as, okay, now be the relationship between depth and PRP? Okay, now this is not really physics, this is common sense. If I ask any of you girls to just, okay, just go to the Dunkin' Donut right next to the school and come back, you will say, okay, that trip is going to take me 2 minutes. Right? Okay. After which, okay, I may send out another girl and say, okay, well, you go to Dunkin' Donut and come back. And she, okay, I'll be back in 2 minutes. Clear? So that time between, yes, okay, sending out the first girl to the second girl, that will be the pulse repetition period. And since, as okay, says, okay, it was a short distance to go and come back, it was going to be a shorter time that you will take to go and come back, after which, okay, another pulse will be sent out. Clear? Where if I say, well, okay, goes, somebody go down, yes, okay, to the highway, and then come back. You will say, okay, that's a greater distance. I may need 5 minutes to go and come back. That's understood. Why? Because it's a greater distance than just walking down to the Dunkin' Donut. Is that clear? So the same applies here. That if a pulse is being sent on a greater journey, meaning it's okay, you travel a greater distance and come back, there's going to be as okay, a greater PRP, or we can directly say it's okay that there's going to be a greater off time or listening time. Because that's actually, that's okay, what the time that the pulse will utilize to travel to a certain distance and return back. Clear? And can we adjust the depth of our imaging? Yes, we can. So girls, actually, that's okay on your consoles. And that's pretty universal, no matter that's okay which console you are looking at. You can say, okay, let's do it this way. You have your keyboard, just like a regular keyboard of your computer. And they're going to, it's okay, be different knobs and buttons. There, it's okay. Some of the other knobs and buttons, that's okay. Arrangement maybe it's okay, a little bit variable. But in all systems, up here, at the right upper corner, is going to be a knob which is going to be saying depth. Is that clear? And this knob mainly as okay works that okay as if you turn it clockwise. Which is this. That will mainly lead to increase. Because it's okay here in this case, it's going to be okay increase in depth. Whereas if you turn this knob here, what some people may call that's okay, anti-clockwise or counterclockwise. Which is like this. That will actually, it's okay, lead to a decrease in depth. But what is it that we are doing by it's okay, either increasing the depth by turning the clock, that's okay, the depth knob clockwise, or decreasing the depth by turning the depth knob anti-clockwise. We actually, as okay, tell the system to increase the PRP. And in this case, that's okay. And the other case, that's okay. We actually, that's okay, tell the system to decrease the PRP. Did you girls get that? So practically speaking, yes, okay, we can just say that, okay, yes. Pulse repetition period is going to be as okay directly proportional to depth. Because it's okay, it's okay, depth of image. Okay. Did you girls get that? Okay. Any questions? So if I send any of you, yes, okay, on a short journey, it's going to be, yes, okay, a quick go and quick come back, right? After which, okay, I may send, okay, as the next one on to the same journey. And you come back soon. So in that case, that's okay, because of a lesser distance, you can say that the duration of the journey is short. Okay, that duration of the journey here is going to be, as okay, your PRP. Did that make sense? Now, when we look at the PRP, as we said, it was the beginning from one pulse to the beginning of the next pulse. Clear? Okay. And now, guys, I briefly mentioned that yesterday. Now, we probably need to clear this out. So we can mainly say, okay, now when we said this whole thing here, is okay, that was your PRP, which was mainly, okay, made up of, we can say the on time, and okay, here's going to be some another on time. Clear? And we said, okay, was the pulse duration, or we also call it, okay, the on time or the talking time. And the off time, or also known as the listening time. Now, as we said yesterday, goes pulse duration, or as okay, what we also as okay context to as okay on PRP referred to as on time and off time is constant. It's by the transducer. Yeah, that was pretty much okay determined by the transducer itself, because okay, how many cycles did it had in a pulse, and what was going to is okay the period of each of these cycles here. That was determined by the transducer. So that's okay as we use one same transducer on time is constant. So the only thing that we are actually is okay able to change in the PRP was its off time, which mainly is okay will give us in this case is okay we can say it's okay a shorter PRP, and in this case here it's okay a longer PRP. But the only thing that was adjustable or changeable was the off time or listening time. Right, okay. Where you can now look here and you can actually see that, okay, so what we have here is this is a short PRP because there's a shorter time period between is okay the beginning of one pulse to the next pulse. Whereas over here, we can say, okay, this is a great PRP because there's a greater time from one pulse to the next pulse. Although, yes, okay, in both instances here, it's okay, the pulse duration of both of these pulses here is okay, were the same because it was still, yes, okay, the same transducer that we used, where the pulse duration was constant as determined by the transducer. Clear? Because it's mainly going to be as okay, how many cycles do we have in a pulse? And what is going to be as okay, the period of each cycle. Clear? Okay. So the period of each cycle that is always okay determined by the transducer itself. What we will see further on is that okay, as is also going to be okay, the transducer is also going to have is okay a fixed number of cycles per pulse, which mainly is okay makes the pulse duration of that specific transducer fixed. So the only thing that we actually is okay change when we change the PRP or adjust the PRP is the off time. And that is mainly as okay, just going to be as okay, why we can say as okay. The depth. So that there is okay as a shorter time between pulse 1 and pulse 2, or a greater time between pulse 1 and pulse 2. Mainly so that okay, these two pulses here do not interfere with one another. Did you ladies get that? Because okay, that interference that is going to yes, okay, then affect your can say it's okay, your image. Right. So in a pulse repetition period, just write it down. The pulse duration or on time or talking time is constant. Clear? Okay. Okay. Now that doesn't mean that it's going to be constant across all type of transducers. Each transducer may have its own pulse duration. And or yes, okay, spatial pulse length. But those are fixed per the transducer. Okay, so when we change the pulse repetition period, it's mainly going to be, well, okay, change by the depth. Okay, but the only thing that we can change in the pulse repetition is the off time. If that makes sense, and just make okay as just make it this way that okay as greater distance would say greater time. Because okay, you are going to be traveling at a constant steady speed. Does anybody have any questions? Now goes next thing, and that's why I say it's okay. This is now going to just okay look more and more and more and more like ultrasound. So you can say, okay, this is A, this is B. This is the image that we get from A. And we can say, it's okay, this is going to be, it's okay, the image that we get from B. Now goes what you may see is okay along the edges of the image. Or as okay, in some instances, okay, out here. Like this. Are going to be as okay, some dots. And what is that? These dots, or yes, okay, may indicate. They will actually, yes, okay, as a whole, yes, okay, indicate, yes, okay, the depth of your image. But it mainly says, okay, this first dot here is okay, that maybe it's okay, the depth 0. This second dot is going to be, it's okay, at depth 1. This is going to be at a depth 2. Likewise, we can say, okay, this one here is okay, that will be 0. Then we have 1, then we have 2, then we have 3, then we have 4. And the main, okay, main says, okay, that, okay, the distance between dot to dot, dot to dot, or here's, okay, dot to dot, dot to dot, dot to dot, dot to dot. The distance between each dot here is going to, yes, okay, be 1 centimeter. So it means, okay, just say, well, okay, from dot 0 to 1 is 1 centimeter, then 2, then 3, then 4. So here we actually, that's okay, have an imaging depth of 4 centimeters. Whereas in this case, yes, okay, we had an imaging depth of 2 centimeters. Okay. Where, okay, here we can make says, okay, whatever structure we see down here is at a 2 centimeters depth inside the body. And we say, well, okay, we need to look at something which is deeper than 2 centimeters. You increase the depth. And okay, the structure was at 2 centimeters up here. That's okay, it's going to still be at that 2 centimeters. But you know, actually, I also going to be able to say, okay, what do we see at, okay, 3 centimeters? What do we see at, okay, depth of, let's say, okay, 4 centimeters. Okay, where you actually can say, well, okay, here we increase, yes, okay, here we have a lesser depth because we only view to 2 centimeters. We increase the depth, and now actually it's okay, able to view at a depth of 4 centimeters. But by doing, yes, okay, by increasing the depth, what did we also tell the system is, well, okay, you know what, buddy? You need, yes, okay, increase the time period between the repetition of pulse 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. Did you girls get that? So please, ladies, this depth here, that's going to be as okay, the total depth of image. Clear? Now just keep in mind, guys, that's okay, the depth of image. That may also as okay be known as depth of view. Clear? Or it may also as okay be known as depth of field. Okay. Now the practically we can say as okay, ultrasound or ultrasound physics is very easy. Because you may be asked, okay, can you increase the depth? Or can you decrease the depth? Yes. Practically, that is very easy. You increase the depth, you decrease the depth. But that comes the theory. What is that going to do now? What is that increase in depth going to do? Well, okay, you can view structures that are deeper now. But what is going to be as okay, its effect on the PRP?
It's going to increase it or decrease it?
If you increase it, it's going to increase.
Mhm.
Because you said PRP was directly proportional to depth. Clear? Okay. But then keep in mind, God, that okay, as within the PRP, the on time is constant. The on time is constant. So it's actually just going to be as okay, only the off time that will change. Yes, go ahead. Yeah.
So only when the PRP, when we're talking about the PRP, the on time is constant.
Yeah. So when we say as okay that we change the PRP, okay, it's only going to be the off time that is going to be changed. Okay, but we still say, okay, that's going to be a greater time from the beginning of one pulse to the beginning of the next pulse. But that's mainly because, okay, we send that pulse on a, yes, okay, greater or shorter journey. And that's why I said, remember that your listening time or off time, that is made as, okay, going to be the time that the pulse takes to go and come back. So it is pretty much, okay, we can say it's okay, calculated, or the system is automatically going to calculate. Okay, yes, what should be the time interval between pulse 1 and pulse 2, pulse 2 and pulse 3, pulse 3 and pulse 4. How will calculate that? Maybe it's okay based on the depth that it has to travel and go back.
Will it always be a centimeter on the dots?
Yes.
Okay.
So the distance between dot to dot, dot to dot, dot to dot is going to be 1 centimeter.
That doesn't change, right? From
No,
one.
that doesn't change.
Okay.
So the distance between, you can say it's okay, one marker and another marker and one marker and another marker is 1 centimeter. Okay. So the distance between them is going to be as okay, 1 centimeter. Any questions? Does anybody have any questions?
No.
So pulse repetition period, the time from the beginning of one pulse to the beginning of the next pulse. Clear? Okay. It is determined by the source. Okay, it is going to be as okay, determined by the source. You as okay, your depth is something that you as okay is determining, or as okay, because in this case, adjusting by the on the source. Okay. Now, and it is adjustable. How? By adjusting the depth. Okay. That's when you can say, it's okay, that there's going to be as okay, a relationship between the pulse repetition period and the depth of your image. Please, girls, it is depth of your image. Okay. It is depth of your image. Is that clear? Okay. Now in your PRP on time, talking time, pulse duration is constant as per transducer. So the actual only thing that we change in the PRP when we as okay by changing the depth is going to be as okay the off time or listening time. And that's why I said yesterday it's okay that listening time. Off time is meaning that's okay the time is meaning it's going to be as okay the time that it takes the pulse to go and come back. After which another pulse is in waiting to go and come back. Another pulse is in waiting to go and come back. Okay. And it's pretty much going to be as okay, the system that will calculate it for you. Okay, what is going to be the time between pulse to pulse, pulse to pulse, pulse to pulse? That's what we call the pulse repetition period. So that's something that the system will calculate, all dependent upon is okay, the depth of your image. A pulse duration, on time, talking time remains constant as per the transducer. So it's only the off time or listening time that we are changing. Right, okay. Any questions? So you girls were asking for a coffee break. I say, well, okay, girls, that's fine. What's a lot? What's hard coffee? Okay, balang raw sa ka. Yeah. So, bye, Mandina. Bye-bye. Okay, sorry. So I will say, well, okay, I'm not going to send all of you girls to get coffee at the same time. You're going to go one by one. Clear? Now everybody is okay, put their money on the disc. Now who wants to go first? Good, so Marianne goes first. Now, you only got 2 microseconds to pick up your money from the desk. That's your pulse duration. And then run and come back. Now, next to go is going to be as okay, anybody else. You will also only get 2 microseconds to, yes, okay, pick up the money from the desk. That's going to be your pulse duration. And then you go and come back. Okay. Marianne, I need you to return back before I can send out the other girl because that's okay. If I send another girl out while you are still on the way, yes, okay, to or back from, yes, okay, the Dunkin' Donuts. You will cross your paths, and then what is it do end up doing? Talking. So that's going to just okay affect our image.
Is that clear? So pretty much, okay, as to avoid interference between sound waves. Or in this case, as okay, we can say pulses. That's why one pulse has to return back before the next one can go. Literally. Right. So that's why it's okay. The system said, well, okay, this is the distance. This is what I estimate as the time that is going to take the pulse to go and come back. So that's your pulse repetition period. Is that clear?
So if an image came back like, you know, foggy or not clear, that means there was an interference.
Don't get into that yet.
Oh, okay.
Okay. Those are, yes, okay, different kinds of adjustments. That's not the point here. Okay. And you are going to be disappointed because, okay, you're not going to see, yes, okay, nice crisp in your images. It's just going to, yes, okay, most of it is going to be shady. Because what happens, okay, we can put it this way, what happens when sound interference happens? What can happen? The amplitude increases or the amplitude decreases, right? So something which should have appear bright may not appear as bright as it should. Or something that might have as okay, actually is okay, produced a weak reflection may appear brighter. Okay. But as far as okay, as the image quality is concerned, you're going to say, well, okay, 90% of it is just going to be as okay. Not 90, 100% of it is just going to be as okay, be different shades of gray. Where you go from as okay, super bright white to as okay, pitch black. But no reds, no yellows, no purples, no greens. Just black and white. And okay, it's the XYZ number of shades of gray. So this is mainly as okay to avoid interference between, you can say as okay, pulse number 1 and pulse number 2. Is that clear, Marianne?
Yes.
Or should I ask what happens when, yes, okay, pulses interfere? What may happen when you have interference? I said it 45 seconds ago. Okay. There are 13 girls who need to look back into chapter number 1 or 2. And you know your quiz is this Friday, right? Do you know the chapters? Of course not. It's chapter 1, 2, 3, 4, and 5. So, okay, girls, there's something that says hint. There is something that says hint. And yes, okay, your pulse repetition period, and that is that your pulse repetition period is not related to period. Do you see that? Okay, so just because both of them are, yes, okay, measurements of time, but girls, your pulse repetition period is not related to period. Now, what was period? The time that it took a cycle. Yeah. No, you can look at that in different ways, but that's okay. The easiest way to just okay understand that is that okay, yes. So let's go here. That okay, yes, this was constant. But we can even say it's okay, even if we had, let's say, 2 different transducers. Wait, let's say as okay. Different durations or different just okay pulse durations or periods. The pulse repetition period could still be the same. Mainly because of the depth being the same. So all those okay, we had a short period or a long period. That is not going to just okay make the period. In this case, it's okay. Even this could have been okay as a short PRP. If he is okay, send it off for us okay a shorter journey, and or vice versa. Even though it's okay, this was a short period, but it's okay, we could still have okay as a great PRP because that PRP was actually as okay determined by the depth or affected by the off time and not the on time. Did you ladies get that? Now, what I would recommend you girls to do is read through your PRP and those of you who still are confused about the relationship between period and frequency, go back to chapter 3 and read period and frequency over again. Because what I said when we did pulse or when we did period and frequency, I said this is going to be a relationship that we will come across again and again and again and again. And that first time again is now. Okay, so I will see you girls back at 10:35. So you got 20 minutes to do your whatevers. right? But read your pulse repetition period. And if you're still in doubt about relationship between period and frequency, make sure that you go and read on your period and frequency as well. And I will see you girls. Okay, girls, welcome back. And any questions? Any questions?
We're good.
Good. Okay, thank you. Now, the next thing that we can say is going to be as okay, we'll recall as okay, the pulse repetition. Frequency. And immediately as okay comes out, right, we can say, okay, what was the pulse that was going to be as okay, because it's okay, a number of cycles would make up a pulse. Repetition here is mainly as okay, we can say it's okay. Repeated. And here frequency, that's me as okay, just going to be as okay, we can say it's okay, the number of pulses per second is going to be the pulse repetition frequency. So we can make it okay, define it as okay, the pulse repetition frequency is going to be the number of pulses per second. Or we can say it's okay, how frequently is it that the pulses are repeated. In 1 second. Now we can just say that, okay, yes, if this period here was a total of, let's say, it's okay, 1 second. And in this period here, it's okay, we had a total of, let's say, it's okay, or pulses. Now, I mean, it's okay, make our ERF, which is mean it's okay, going to be as okay, the abbreviation for pulse repetition frequency is going to be equal to say as okay, or pulses per second. Or this could also be as okay, we could say as okay, or here is okay, this pulses per second here It's just going to be as okay, be the hertz. Okay, because okay, it's generalized or standard unit of frequency still is hertz. But it's okay, it's going to, it's okay, not the number of cycles per second, but the number of pulses per second, because which means, okay, said that is the pulse repetition frequency. How frequently does a pulse get repeated in a specific period of time, which in this case, it was 1 second. Did you girls get that? Okay, so as far as the unit, or yes, okay, the pulse repetition frequency is concerned, it could be as okay, just the number of pulses per second, or it could also, as okay, be expressed as okay, the general unit of frequency for, which is going to be hertz. Okay, but this number here is okay, as you said here. That is not the number of cycles per pulse. It's not going to be as okay the number of cycles that we have in 1 second. But it's actually going to be as okay, how many pulses do we have? If you put in as okay, as if you had okay as an extra pulse, that's that was a pulse here too as well. Okay. And okay, it was going to become 5. If you had another pulse, it's going to become 6. Right. So here's okay, that's frequency is okay, is going to okay be taken into context related together with these 2 terms here, which is going to be the pulse repetition frequency. How frequently is it that a pulse is going to be repeated? That is going to be the pulse repetition frequency. How frequently is going to be repeated in this okay a standard unit of time, which will be 1 second. Okay, so its unit can either be as okay pulses per second or hertz. But it doesn't become period, it becomes not a frequency, but it actually is going to be as okay be the pulse repetition frequency would be 4 hertz, because there were 4 pulses in 1 second. Did you girls get that?
Yes.
Okay, anybody is in the least doubt? Okay. Because had it just been frequency, then that frequency remained as okay, be it how many cycles were completed in a second. Okay, that will become yes, okay, the frequency. Okay. Or even here, it says okay, if this was okay as the frequency of the cycles in the pulse. But as okay, from this we can say as okay, say okay, what will be the frequency of cycles in a whole second? Now, ladies, so the unit for your pulse repetition frequency can either be as okay, be not cycles per second, but it's going to be pulses per second. Clear? As far as the typical value is concerned, or your CRF, sorry. Don't worry about it. Okay, it's not a value that you need to just remember. Okay, so as far as the typical values for your PRF, and we can say PRP. Don't worry about them. The main thing goals is going to be as what determines your PRF. And again, goals, it is going to be as the same that determines the frequency, which will be source. Okay. And we can say, it's just like the PRP is also going to be determined by the depth of image. But that's mean is we can say, how will we be able to just adjust it? Just as we did with the pulse repetition, period. So again, are we able to adjust it? Okay, no, that's okay. Whenever something is adjustable and the answer to this here is yes, Since the answer is yes, then the next question becomes how? Just like in the previous chapter, yes, we said power was adjustable, intensity was adjustable, and amplitude was adjustable. And the question just came out at the next question then was, since it is adjustable, how? In that case, it was mean as just by changing the, what we call the power output. Okay, and just keep in mind, girl, just if anything is adjustable on your system, there gotta be as a knob, or there gotta be as something is that you can touch on the touch screen of your system that actually is makes it enable you to change it. Clear? So here is the how is, the answer of the how is, again, is by changing, or we can say it's adjusting the depth of view. Did you girls get that? So we can say it's the mechanism by which we adjusted the PRF. Is the same as the mechanism by which we adjusted the PRP. By changing the depth of view. Did you girls get that? Anybody in doubt? Now, do I have Dr. Giraldo? Are you there, my dear?
Yeah, I am.
Okay. Do you mind telling me the relationship between period and frequency?
It's inversely related and reciprocal.
And reciprocal. Clear? And now if we just look at it, because that's made as okay, going to be as okay as similar, not just similar, exact similar relationship between PRP and P. That okay as they were inversely proportional, just like period and frequency were inversely proportional. They were also reciprocal, which means okay, mean that PRP multiplied by PRF is going to be 1. Just like okay, as when we multiply period by frequency, it will be 1. So this here is okay, meaning is okay, just proves that okay, as they are inversely related. And this means is okay, this one here just proves that they are reciprocals. So let us just take an example of, let's say it's okay. So we're not going to be bar, but you can see this relationship here is mainly it's okay, just being repeated again, because okay, what we did here is okay, period is measuring something in time. Frequency is just as okay, how frequently does it occur? Just like the PRP mainly is okay, was just as okay, what was the time between pulse to pulse? Where the PRF is mainly as okay, just going to be as okay, how frequently does the pulses get repeated in a specific period of time, which is an example of the frequency of the pulses. So they are going to as okay, be inversely proportional and reciprocal. What did it mean to be inversely proportional? And if this increases, then this will decrease. And vice versa. If they decrease, then this one here will increase. Yep. So just to make it simple, girls. That may not be as okay realistic, but anyway. Then we say, okay, if this here is okay, was 1 second. Okay. In one instance, let's just say that, okay, as in one instance, yes, okay, we said we have let's say it's okay, 4 pulses in 1 second. Yeah. Where in this case, if we can say it's okay, we have okay, it's 1, 2, 3, 4, 5, 6, 7 pulses in 1 second. Is that clear? So we can just label this one here as A and this one here as B. because we can then say that, okay, as our pulse repetition frequency in this case is going to be as okay. You can say it's okay, 4 cycles, oh, sorry, not 4 cycles, 4 pulses per second. Or you can say it's okay, we're having a PRF of 4 hertz. Clear? Whereas down here, we can say, okay, we had, okay, 7 pulses per second, right? Okay. So yes, okay, in this case, yes, okay, the PRF was going to, yes, okay, be, yes, okay, sorry, 7 pulses per second. Or we could say, okay, that would have been also, or having a PRF of 7 hertz. Now, when it comes to the period, or we can say, okay, the pulse repetition period, that's going to be the time between pulse to pulse, pulse to pulse, pulse to pulse, and pulse to pulse. Okay, so it immediately says, okay, since there are 4 pulses in 1 second, that will mainly mean that, okay, as the PRP. In this case, is going to just, okay, be 1/4 of a second. Clear. Whereas down here, it's okay, the PRP is going to be, because we had 8 pulses in a second, the PRP is going to be 1/7 of a second. Okay. And although not even, but what we mean, you can say, okay. But what do we see here? Okay, we says, okay, when comparing, okay, let's take a little brighter color. Let's take this one here. These are all off times. Or we can say, okay, comparing this PRP to this PRP. This is going to be as okay, ideally speaking, it's okay, these distances or these orange lines should have been even. But anyways, yeah, okay. That we actually is okay. In this case, is okay. We say we have a low PRP, which gave us an equally high PRF. Okay. Whereas over here, we have a great we have a low PRF because of a great PRP. And what caused it just to have is okay, a great PRP here is mainly is okay, great off time. And this low PRP is mainly is okay because of a shorter off time. Where you mainly will say is okay, in this instance here is okay, what we are going to have is, sorry, a great depth of image. Whereas in this case here, it's okay, we are going to have a low depth of image. Are you lost?
I'm a little confused.
Okay. What are you confused about, my dear?
So what number is considered low and what number is considered like high? Like what's the mark that it has to meet?
My dear, for a number to be high, for a number to be low, okay, guys, now just look at the numbers that we have here. Vika says, okay, in one case, we said that, okay, yes, the frequency was 4. Clear? And okay, yes, the period is 1/4 of a second. Is that clear? Okay. Or we can say, it's okay, it's actually going to be, it's okay, not period, it's going to be the pulse repetition frequency and the pulse repetition period, sorry. Clear? Whereas in the other instance, now, okay, that's all that we say is okay, 8, 7, but we can just change it to, let's say it's okay. I said, okay, we have okay, the pulse repetition frequency of, let's say 8. And okay, as in this case, it's okay, the pulse repetition period is going to be, it's okay, 1/8. Is that clear?
Yeah.
Good. Now, my dear, when we look at the PRFs in both these instances here, which number do you think is greater?
8.
8. So you says, okay, that's going to be as okay, a high pulse repetition frequency. Because you have, okay, as 8 pulses being repeated in 1 second, which mainly as okay, or me as okay, this PRF here, the low number, right?
Yeah.
Did that make sense?
Yes, it did.
Good. Now, on the other hand, now go, my dear, yes, okay, if you look at these two numbers here, 1/8 versus 1/4. Okay. Now what 1/8 actually means, let's say it's okay that this was okay as a piece of, this was a cake. And likewise, it's okay if this was a cake. Even size cakes. But here is okay, what was it that we did? We sliced this cake here into 8 pieces. Did that make sense?
Yeah.
Good. Whereas over here, you can say, okay, this was a cake we made, it's okay, just made it into 4 pieces. So what is 1/8 going to mean? That okay, as and 1/4. There are two similar cakes or pizzas or whatever you want to have. Clear? But one pizza was sliced into 8 pieces. And the other pizza is sliced into 4 pieces. Now, if I say, are you very hungry? Then you get a big piece. And if you're not that hungry, then you may get, okay, it's a small piece. Does that tell you which number is bigger now and less smaller now? Okay. So 1/8 actually is okay, is a lower number. Yeah, 1/4 becomes this, okay, greater number. There you can say, okay, 1/4 of a second. Let's just say that there was a clock of 1 second. This was okay, it's okay, a clock of 8 seconds or 1 second. But it's okay, you can still say it's okay that the time it would take your pointer to go from this point to this point, from this point to this point, from this point to this point, from this point back to this point. It's going to, as okay, be 1/4 of a second, which is the quarter of a second. Where you can say it's okay, the time that would take to get from here to here is going to, as okay, be 1/8 of a second. Which actually is going to be, it's okay, lower time compared to here. It's going to be, it's okay, greater time, which we account for here and here. So this number here is going to be, because it's okay, there will be, it's okay, a greater time, which make it okay, it's a greater pulse repetition period. So it's going to be a greater time between, it's okay, pulse number 1 and pulse number 2, 2 and 3, 3 and 4, 4 and 5, and so on. Which mainly causes, okay, as there's going to be, as okay, less number of pulses being repeated in 1 second. Did that make sense? Where here we say, okay, 1/8. That is actually, is okay, a smaller number. Or you can say it's okay, a smaller pizza or slice or piece of the cake or pizza or whatever. Okay. And what makes this and this here is okay, reciprocal is okay when you multiply them, you get 1. Likewise is this, and this also going to be reciprocal because it's okay when you multiply them, you get 1. Did you get that?
Yeah.
So at any point, it's okay if you are confused. You can say, well, okay, as a pizza was cut into just 4 pieces, 10 pieces, 100 pieces. The more number of pieces you cut the pizza into, The smaller and smaller is it that the piece is going to become, right? Right? Good. So that was it. So let's just go on again. Let's see. That okay. Let me make it a little more. So it says, okay, this was a total time of 1 second. I think it's okay, total time of 1 second. One second. So it's okay. We made this okay. The next pulse will be here. Let me just make the pulses first, and then we can always just okay draw the. So if you can say it's okay. Pulse. Another pulse. Another pulse. Another pulse. Another pulse. Another pulse. And another pulse. So again is okay. If this again is okay was 1 second. Okay, what we mainly have here is just okay, we have 1, 2, 3, 4 pulses in 1 second. So that becomes just okay that the PRF is, we can say it's okay 4 hertz, or we can say it's okay that would have been it's okay 4 pulses per second. Here. Whereas okay, on the other hand, we can say it's okay the PRP. In this case, is going to be as okay 1/4 of a second. Likewise, down here, we can say it's okay that we have 1, 2, 3, 4, 5, 6, 7. Okay, maybe we should, okay, yes. Just to make it a little bit more okay. And we'll say it's okay. This there will still be it's okay 1 second. Yeah. Where we made you go say it's okay. And okay, so and okay, it's 1 pulse here. Just where we made you can say that okay, yes. In this instance is okay here, or PRF for B, 8 hertz, or what we also gonna say it's okay, 8 cycles per
second. Yeah, which mainly mean that, okay, as the pulse repetition period is going to be as, okay, 1/8 of a second. Okay, so means, okay, there's going to be time from here to here. From here to here, 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 and okay, from here to here. Now, girls, I hope that you all will realize that, okay, yes, since this pulse repetition period here was great, the pulse repetition frequency will be low. Clear? And okay, yes, in this instance, we can say is okay here. Our pulse repetition frequency will be great because we have a lower pulse repetition period. Okay. And since we said that, okay, yes, it is adjustable. How? Mainly because what gave us, okay, as a high pulse repetition period in this instance here was made as, okay, because we had a great off time. Clear? Which mainly as, okay, in this instance, okay, we have a low pulse repetition period, mainly because there's a lesser off time, or a lesser time between pulse to pulse. Is that clear? And what does this lesser off time and lesser PRP indicate? Vice versa, what does this great PRP due to is, okay, a great off time indicate? In this case here, we actually is, okay, they can both be related to depth. Where we made it, I can say it's okay that less PRP due to less off time is because of a less depth, because the pulse has to travel a short distance to go and come back before it's, okay, the occurrence of the next pulse. It's travel a short distance to go and come back because before the occurrence of the next pulse, and so on. So in this case, that will be the case of a shallow depth or a low depth image. Whereas here, we have a great depth. Comparing these two. Okay. And all these relationships that you see here, whether that is the relationship between PRF and PRP, PRF and depth, PRP and depth, and likewise here.
These are super duper must to knows. Okay. So if I say as okay, two transducers with different PRFs, a high PRF and a low PRF, which will be as okay, imaging to a greater depth. It will be the one with a low PRF because of a great PRP, because of a great depth. So that example that I gave you girls earlier, going from the school to the Dunkin' Donut and coming back, that was a short distance, right? Okay. And if I say, well, okay, how many trips? Let's say that, okay, as a take you, yes, okay, 1 minute to go to the Dunkin' Donut and come back. So how many trips are you able to, let's say, okay, make in 10 minutes? 10 trips. Now the period or the repetition or the period for the each journey back and forth, that was your pulse repetition period. That was low. That caused that you were able to just, okay, make a great number of trips in a fixed period of time. We said 10 minutes, right? Okay. Did that make sense? Why? Because, yes, okay, that was a short distance. Compared to, yes, okay, if I now tell you, well, okay, go, what you have to do is go from the school all the way down to the highway and then come back. And let's see how many trips you can make in 1 minute, in 10 minutes. Now that's a great distance, right? Since it's a great distance, it would take you as okay a longer time to make each trip. Let's say it's okay, it takes you 2 minutes to make a trip from the school to the highway and back. That becomes your PRP, which is greater than what it was to making a trip to the Dunkin' Donut and back. But then comes the next question is, okay, how many trips are you able to make in a minute, in 10 minutes? If it takes you 2 minutes to make one trip, you can only make 5 trips in 10 minutes, right? So that becomes your PRF, which is going to be low. Did that make any sense? So the thing here that actually is, okay, change your PRP. Also is, okay, change your PRF inversely and reciprocally. Did that make sense? So the easiest cheat is just as, okay, yes, okay, a longer journey back and forth is going to take me longer time. That longer time in this case is going to be a greater pulse repetition period, which way is okay, make me is okay, only be able to just okay, make a lesser number of trips in a fixed time period. That lesser number of trips in a fixed time period is going to be as okay, we can say it's okay, a lower PRF. So you can say it's okay, the greater the distance or greater the depth, lower the PRF because of a greater PRP. So PRP and depth are directly proportional. Clear? PRF and PRP are inversely proportional and are also as okay reciprocal, just like period and frequency were inversely proportional and reciprocal. So since depth and PRP were directly proportional and PRF and PRP were inversely proportional, that makes PRF and depth inversely proportional as well. So whichever way you want to write it, okay. You can do it this way. And just say as okay, make it straightforward. We say as okay, PRP. We go PRF. And we go depth. But we mainly can say as okay that if the PRP increases, we will have a lower PRF. And that will mean a greater depth. Or on the other hand, a lower PRP means a greater PRF, which will be a lower depth. As okay, as here, the change into a PRF or PRP. Mainly as okay, it's just going to be as okay, the change in off time, or we can say it's okay, listening time. Why? Because in the whole PRP is okay, pulse duration is constant. Any questions? Now again goes one thing that you need to remember, and don't confuse it. Your PRF is not related to the frequency. Which mainly or mean that you can have, okay, as a transducer with a high frequency or a low frequency. That high or low frequency of your transducer is not going to, cause the PRF to either increase or decrease, because these two factors here are not related. Okay, so you may get tricked into being given a question where they say, you have two frequencies, one with a, let's say, frequency of 2 megahertz. Or let's say 12 megahertz. Okay, and as another frequency of the transducer, which is, let's say 6 megahertz. And then they may ask you, which of these two transducers here will have either the greatest PRF or the lesser PRF. But for both of these three transducers, their PRFs is going to be equal. But that is provided that the depth of image is the same. Okay. So likewise, they may say, well, you have two transducers with the same frequency. But let's say different PRFs. Now, which of these two transducers will have greater or lesser imaging depth? The one is going to with a lower PRF. That is going to have the greater depth. And this one here with a greater PRF is going to have the lower imaging depth. So although PRF is a type of frequency, but it counts for the frequency of your pulses. Has no relationship to the frequency and frequency alone. Because here that's going to just be the frequency of, because that's of the cycles. This frequency, is going to be the number of cycles per second. Okay, so these two here are not related. So the frequency of your transducer is not going to change just because you increase the PRF. How do we increase the PRF? Is there anybody who can tell me how we increase the PRF? What can we do to increase the PRF?
Change the depth of view.
Pardon me?
Change the depth of view.
Okay. Change the depth in what way? Now I'm becoming an a-hole. What change in depth would increase your PRF?
Moving it clockwise.
Pardon me there?
I said moving it clockwise.
Okay, that's how you. Okay,
Decreasing the depth of view.
decreasing the depth is going to, yes, okay, increase your PRF. The relationship goes, the arrows up and arrows down. The purple arrows tells you, yes, okay, the relationship between PRF and PRP. PRP and depth. PRF and depth. So does the brown waves or brown arrows. That okay, as when we increase the PRP, the PRF is decreased. When we increase the PRP, that's because the depth is increased. And as the depth is increased, as the PRP is increased, the PRF is decreased. But which mainly is okay, all is okay, can just be is okay. If you want to break it up and make it more complex for yourselves, that's fine. That just makes you just okay, have to remember more relationships. Not more, but then we can say it's okay. PRP is inversely proportional to PRF. We can then also say that okay, yes, this PRP here is directly proportional to depth. Where we then also can say that okay, yes, the PRF is inversely proportional to depth. Which mainly mean that okay, yes, if this increases, this decrease. This increase, this increase. This increase, this decrease. Or the other way around. This decrease, and this increase. This decrease, and this decrease. This decrease, then this increase. Whichever way. So all this here on one index card is equal to all this here on an index card. Any questions? But then yes, okay, also just remember that okay, yes. Sorry. PRF times PRP equals 1, and that's why we said okay, these two here is okay were
reciprocals, which mainly mean that did we have, let's say, as okay, 1,000 pulses per second. That means okay, make a PRF to become 1 kilohertz. What that will call that okay as the PRP, or be as okay 1,000 of a second. Or could also be as okay expressed as 1 millisecond. Or we go to another extreme and say as okay, one million pulses per second. That means yes, okay, because that's okay, that's going to be the PRF as well. Or actually, it's okay, be that the PRF as well, okay, could be yes, okay, 1 megahertz. Where we mainly going to say, okay, the PRP then would be the PRP in this case here will be as okay 1 millionth of a second. Or we could actually say, okay, what had been 1 microsecond. Which made PRP and PRF reciprocal. Because, okay, in this case, it's okay, where we multiply 1,000 by 1/1000. But we still get was 1. Because as far as the units were concerned, yes, okay. A kilo was 1,000, a million was 1,000. These units, yes, okay, were reciprocal. Or these times and fraction of units, yes, okay, were reciprocal. Just like, okay, as 1 million was 1 mega. 1/1,000,000 was a micro. So it's okay. But even as okay, we multiply as okay 1 million by 1/1,000,000. The power was 31, which made them reciprocal. Just as okay, we had 1 million pulses in a second. We can then say as okay, the time span between pulse and pulse, pulse and pulse, pulse and pulse will be 1 microsecond. Because as far as the mega and micro was concerned, they were reciprocal. One means 1,000,000 times. This was 1/1,000,000 times.
Did that make sense? Clear? So girls, just okay, that relationship of period and frequency, you better be on top of that one, because I said this was just once. It's going to come back again and again and again. The 4 times that is going to be there. Almost period frequency, we already did that one. But then we had 3 agains. The first again is over. But if you understood the relationship between period and frequency, you understand the relationship between pulse repetition period and pulse repetition frequency. The only difference between frequency and pulse repetition frequency is that when we say frequency, it's going to be as okay the number of cycles per second. But if we say pulse repetition frequency is going to be as okay number of pulses per second. Or in a time span of 1 second, how frequently is it that a pulse is going to be repeated? Clear? That becomes the frequency. Which is inversely proportional and reciprocal to the time span between pulse to pulse to pulse to pulse, which becomes the pulse repetition period. Where we said plain period, that was means, okay, just what's the time that it takes for 1 cycle to repeat or complete. But just like period and pulse repetition period were interrelated or not related, likewise is pulse repetition frequency and frequency are related. Okay, girls? So again, yes, okay, things that I yes, okay, mentioned in your hint boxes, and people yes, okay, that's that just look there. It's just there to look beautiful. No, it is highlighted in a box for a reason, to attract your attention. So that's something that okay, you have to yes, okay, you can say about bang in here, because you will get questions that's okay where you will feel tempted. Ah, okay, the frequency increases and the PRF is also going to increase. Or vice versa. So what means to be unrelated is, well, okay, you can increase one of them as much as you want to. It's not going to have any effect on the other factor. Okay. Any questions? Good. Then, ladies, what you will be doing is you will take on your lunch break. And whether you do that before your lunch break or after your lunch break, but that's okay. On page 59 in your book, there are a total of 8 questions. Now look at those questions. Try to see if you can answer them by covering up the answers, okay? Don't look at the answers, okay? First, see if you can figure out the answer, and okay, then check it with the answer that's okay given in the answer key. And I see you girls back at 12 o'clock. And then we will talk about it. Okay, yes, no, okay, 12:55.
Sorry.
And then we will talk of duty factor. Yeah. Have fun. Okay, ladies, welcome back. Now, does anybody have any questions? No? Did any of you try to answer the questions on page 53 or 50, sorry, 59? Any of the questions giving you an issue? No? Okay, goes. And we can just go on to the next topic, and as a matter of fact, that's okay, the last of this chapter here. Which we'll call is okay, the duty factor. Okay. Good. And ladies, the duty factor, first of all, is okay, that's going to be as okay a percentage of the PRP. Which is the pulse duration. Yeah. Now goes when we say as okay percentage. What we mean by a percentage of that's going to be as okay out of 100. Yeah. Of the PRP is going to be as okay the pulse duration. Now just keep in mind that this pulse duration it can also is okay be called talking time or on time. Now, ladies, if you recall earlier this morning, and even yes, okay, yesterday I said that your PRP. If you said, okay, that this was one pulse, and okay, this was another pulse beginning here, right? Okay. And this whole here is okay, becomes your PRP. Was actually it's okay made up of 2 times. It was on time or talking time or alteration plus in this case as okay your off time or because it's okay listening time. That makes the PRP. Okay, so the sum of these 2 times periods, yes, okay, that will make your pulse repetition period. Because once that is finished, yes, okay, you will see that, okay, as your a new pulse will be repeated. Did that make sense? Okay. So what they mainly say is, okay, how much percentage of this entire PRP here is going to be as, okay, your on time. That will be considered as, okay, the duty factor of your that will be considered as, okay, the duty factor. Is that clear? Now, one thing, and okay, as we're going to come back to that is, okay, when we get to, yes, okay, the typical value for your PRP. Although, yes, okay, it is a percentage, but it is not expressed as a percent. As a matter of fact, this is going to, yes, okay, be one of the things which actually is, okay, will be, yes, okay, what we're considered unitless. So it's mainly as, okay, just going to be a number. It could be a number of, let's say, 0.1. Or as a matter of fact, okay, 0.001. Or 0.00001. Or yes, okay, it could even, yes, okay, be 1. Okay, but it's going to be unitless. So there's not going to be as, okay, you're not going to say as, okay, saying 1%. You're not going to say it's, okay, 0.1% or 0. So and so percent. Okay, it is always going to be as, okay, expressed as just a number without a unit. Did you get that? Now, in this case, I can say, I could just say, okay, as the PRP, for instance, okay, it was 1 second. Your PRP here is, okay, was 1 second. Okay. There, okay, within this 1 second, we can say, okay, that the on time or pulse duration was equal to, yes, okay, let's say it's, okay, 0.1 second. Which means, okay, just for me, it's, okay, 1/10 of a second. So in this instance, okay, because mainly says, okay, that, okay, yes, the duty factor was going to be, yes, okay. Because says, okay, that would have been 10%. Or, but as you said, okay, this 10% range is, okay, will mean that, okay, yes, our duty factor was going to be, as, okay, 0.1. And then you see as, okay, here, there's going to be, as, okay, no unit. How we get to that, yes, okay, we will do, yes, okay, some examples with the math in a little bit. Whereas if we on the other side says, okay, let's just assume that, okay, it's here. They will say, okay, the PRP was 10 seconds. And our pulse duration was still is, okay, 0.1 second. In that case, it's okay, the duty factor would actually is, okay, be a percentage of 0.01%. Oh, sorry. Okay, we said 10 seconds. Sorry. It would just have been as okay 1%. And that 1% actually is okay, would be 0.01.
Quick question.
Yes, my dear.
So that 0.01 will not have nothing behind it because it's going to be
Exactly,
unitless.
exactly. Because if you rolled 0.01%, that will actually as okay mean 1/100th of a percent. Okay, but you can maybe say it's okay that your entire yes okay what the hell you call it? Okay, PRF, oh sorry, PRP, sorry, was 10 seconds. And at that 10 seconds, yes, okay, 0.1% or 0.1 of a second or the 10th of a second was your pulse duration. Then the duty factor was me, it's okay, just going to be account or how much of these 10 seconds here is your on time. Right, okay. That will be yes, okay, your duty factor. Okay. But as okay, if you write it as a person, in this case, okay, it will be 1%. But say as okay, duty factor is unitless. That's why as okay, that 1% is going to become as okay 0.01. But if you then write person here, that's going to mean that you're actually talking about as okay 1/100th of a percent. But that's actually going to be as okay a fraction of a second of a percent. Is that clear? So we say yes, okay, 10%. That's going to yes, okay, be just 0.1. 1% is going to yes, okay, be 0.01. And so on. Now, girls, here again, yes, okay, we can say yes, okay, the typical value for diagnostic imaging. And what, okay, as we have a range where we can say, yes, okay, the lowest duty factor is going to yes, okay, be yes, okay, we can write it as either 0.002. Whereas, okay, as the highest may be 0.005. And you see that, okay, none of these here has a unit. So this 0.002 here can actually as also be equal to 0.2%. Where, okay, as the maximum here is going to be 0.5%. Where 0.5% mainly as okay just means 0.5%, not even a full percent. Did you ladies get that? So whether it was just, okay, the lowest value here in the range or the smallest value here in the range, what you mainly can see is that, okay, yes, if this here is, okay, is a span of, okay, as one PRP, okay, where we may say, as okay, we may as, okay, have another pulse starting here. But this here was the whole PRP, which was mainly as, okay, was going to be made up of both on time plus off time. Okay, but you mainly will see that it's going to just, okay, be a very, 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 very small fraction of this entire timeline here, which is going to be on time and something like this will be the off time. Is that clear? So if you go and say it's okay, 0.02%, if that's going to just, okay, that's your on time. In this case, we can mean it's okay that 99.8% of your entire PRF or PRP, sorry, is off time. Whereas if you go and say it's okay, that your on time was maybe it's okay, just 0.5% of the entire PRP. That would mainly mean that, okay, as the remaining 95 or 99.5% of the entire time of your PRP was off time. Clear? So these are going to be, it's okay, we can say it's okay, the main typical values expressed as, okay, as numbers or as percentages or as, okay, a pulsed wave transducer. Okay, and these values here or your transducer or pulse wave transducers. Memorize them. Now just watch what I wrote here is okay, that these are the values for just okay for a pulsed wave transducer. Now, if you look in your book, and there's that table as okay, and when they talk about typical value, there's a second paragraph that starts with okay, as the duty factor of 1 is 100%. Now you can say it's okay, if your duty factor is 100%, there is going to be, it's okay, a duty factor of 1. And what that mainly mean? That mainly mean that it's okay, your entire PRF or PRP, sorry. Your entire PRP is an on time. And if the transducer goes on like this and doesn't keep its mouth shut, what do you say that would be? That is going to be, it's okay for a continuous wave transducer. So that we have, okay, as a duty factor of 100%, that you can say it's okay, the entire PRP was on time. Which mainly means that, okay, it's 100% on time. Clear? But that 100% is okay expressed as a unitless figure is going to be 1. Clear? That we say is okay, the time from here to here was, let's say it's okay, 10 seconds. The transducer is on for 10 seconds. That makes yes, okay, a continuous wave. This was, let's say, it's okay, 100 seconds, and okay, the transducer is on for 100 seconds. I mean, it's okay, continuously producing sound because it's not taking breaks, because it was not a pulsed wave transducer. Then in that case, it's okay, your duty factor is going to be, it's okay, 100%. Or 1. Okay, so please make sure that you mark that paragraph. Let's say the duty factor is 1 or 100% for a continuous wave sound because the sound system is always transmitting. Or we can say it's okay, it's always or it's continuously transmitting. No breaks in between, no off time, nothing. So all time is on time, that's a continuous wave transducer. There's your entire PRF, if that's what your entire PRP, sorry. From here to here is okay, we say 10 seconds, it's always on. If it's 100 seconds, it's always on. If it's 15 hours, it's always on. Right? And again, that's okay, please make sure that it's okay, you know that these could also be called therapeutic transducers, or we could also refer them to as, okay, as non-imaging transducers. Why are they now? Now you should be able to say, okay, why they are non-imaging. Because they don't take the break to let the pulse travel, come back. Did that make sense? Did that make sense?
Yes.
Yes.
Good. Anybody in the least doubt? And again goes. What is it going to be determined by, or what is it that your duty factor is going to be determined by? Well, you can say, well, okay, it mainly is okay, it's just going to be as okay, the percentage of your entire PRP that is made up of the on time. Or pulse duration, or talking time. And that talking time itself, yes, okay, was determined by the source. So that's okay, your PI is okay, the duty factor, just like the pulse duration, just like, okay, as you can see, it's okay, the spatial pulse length, just like period, was going to just okay be determined by the source as well. Okay. The next thing comes. Is our duty factor, is that adjustable? Is that adjustable? Which means, okay, can it be changed? Can we either, yes, okay, increase or decrease the duty factor? Well, indirectly, yes, we can. So it's okay, since we said yes, it is adjustable, then the next question just comes. How? And if you just look at, okay, as what is going to, yes, okay, make up the duty factor, you can actually say, yes, okay, that should give you the answer. Because your duty factor mainly, yes, okay, was the pulse duration. You could call it pulse duration. The on time, we can call it a talking time. It doesn't really matter. Yeah. Or okay, you can say it goes under those two names as well. Okay. But we already said that okay, as pulse duration is okay for a specific transducer, that was fixed. So this fellow here is okay, he or she was not adjustable, right? Because okay, that was going to be constant. But then comes the other thing that we actually is okay, divide this pulse duration with to determine as okay, what will be as okay the duty factor. And that is okay as your PRP. So mathematically, as okay, duty factor is mainly as okay, just your pulse duration divided by the PRP. And since we said it is a percentage, well, okay, you got to multiply by 100. Yeah, we can say, okay, this number here as well is still going to, okay, be constant. We can't make this 1,000. We can't make this a 10. We can't make it a 10,000. It is going to be 100 because after all, okay, the duty factor is a percentage. Is that clear? So the factor actually is going to be that, okay, yes, the duty factor can be changed by changing the PRP. And how do we change PRP? By changing the depth. Did you guys get that?
Yes.
Good. Now we can then just say, yes, okay, let's just put all these relationships here together. Now, or we look at the equation. Let's just first look at the equation because then it's going to, if you can always say, okay, say that will be easier. So we can say, okay, duty factor. Now that is mainly as okay going to be as okay directly proportional to the pulse duration. Okay, so duty factor is mainly as okay going to be as okay directly proportional to pulse duration, which mainly will mean that okay, yes, the greater portion of your entire PRF that is constituted of the on time, the greater will be the percentage of your PRP, sorry, that is going to just okay be on time, so that you have a greater percentage, and vice versa, of the PRP being on time, and vice versa. And girls, if you look at this equation here, you should already be able to say, yes, okay, what the relationship between pulse duration, no, it's not pulse duration, sorry, your duty factor and PRF is. Not a PRF, sorry, PRP. We can always bring in the PRF later. Yes, girls. In this equation, what is it that your PRP is?
Inversely,
It is the denominator, right? And what did I say once, not so long ago, that you should already have forgot about it? That's always okay. The denominator is always going to be as okay inversely proportional to as okay whatever we are calculating. Clear? Now, since we then already know that, okay, yes, the PRP then happens to be as okay directly proportional to depth. Right? That just gives us okay as our other equation, or as okay our other relationship. That okay then is it that okay the duty factor also is going to be as okay inversely proportional to depth. Clear? Whereas again, yes, okay, on the other hand, we can say as okay, duty factor, while okay, as is inversely proportional to PRP, is inversely proportional to depth. But we don't have to go that long. We can actually say it's okay to we already know that okay, as PRP was, sorry, going to yes, okay, be inversely proportional to PRF. So that also yes, okay, makes it okay, PRP or PRF directly proportional to duty factor. Did that make any sense?
Yes.
Good. And girls, you know, whenever we talk relationships, all these relationships are much to know. So you may not necessarily have to do, yes, okay, the math. Not necessarily. Okay. But if they say, yes, okay, two pulses with same pulse duration. And let's say it's okay, same imaging depth. They will have the same duty factors. If it's two pulses with same pulse duration, but one is imaging at a depth of, let's say, 3 centimeters, one is imaging at a depth of 6 centimeters. GMT says, okay, the one with a 6 centimeter imaging depth has a twice the PRP as that of the pulse imaging at a depth of 3 centimeters. So the one with the greater depth is going to have or greater PRP is going to have as okay, lesser duty factor, and vice versa. Okay, let us just look at an example. Let's say girls, what to begin with? How do we get okay calculate the duty factor? So duty factor is mainly as okay is going to be, we can say as okay the pulse duration. Okay, which will be divided by as okay the PRP, which we have here, this black line here. Okay, and okay, yes, since it is a percentage, as okay at the end is okay, we may have it's okay multiply that by 100. But I will give you guys as okay a cheat where you don't really need to as okay do the multiplication by 100 and still get your duty factor. Now we can yes okay just for the simplicity's sake that okay yes our time of the PRP here is 10 milliseconds. Okay. Where we yes okay I can say that there says okay, our PRP, not PRP, sorry, pulse duration, sorry, on time maybe yes okay just 10 microseconds. Now girls, what some people may do, and that's because they think that microseconds and milliseconds is one of the same thing. And they go, yes, okay, say, yes, okay, 10 divided by the 10. And you can say it's okay, then it's okay, multiply by the 100. So what they actually is okay, and I'm saying it's okay, 10 cuts 10. And they'll go as okay, 100, and they'll go as 100%. Right, okay. And does this look like, okay, yes, that your 10 microseconds was the same as 10 milliseconds? Huh? So one thing that you gotta be watchful for, because otherwise, yes, okay, you will choose the wrong answer. And this answer is okay, 100% or 1 may be given. Is that okay? You have to make sure that both of yes, okay, your pulse duration and pulse repetition periods are in the same unit. Now there are two ways of doing it. Either yes, okay, you can say it's okay, these 10 microseconds here. Oh, sorry. You can do it this way and say it's okay. These 10 microseconds here is okay, they're going to be equal to how many milliseconds? Or you can do it the other way and say it's okay, these 10 milliseconds here is going to be equal to, yes, okay, how many microseconds? Now, if you want, yes, okay, fine, yes, okay, what is the worth of 10 microseconds being expressed in milliseconds? Well, okay, you will say, well, okay, this 10 here is okay, has to be divided by 1,000. Or if you want to go the other way around, say it's okay, 10 milliseconds is equal to how many microseconds? You would have to, yes, okay, multiply this here by 1,000. Either way. So if we do it this way and say it's okay, we divide the 10 microseconds because we want to find as okay what their worth is or how much it's going to be as okay being expressed in milliseconds. We can say it's okay, easily this cuts this and it become 1 divided by 100, which is going to be 0.01. So these 10 microseconds here actually is going to as okay be 1/100th of a millisecond. Or we can say as okay, 10 millisecond actually is going to be as okay, 10,000 microseconds. So either way, don't do both. Clear? Because we may as okay, just want to make sure that okay, this unit here was converted into this, or this unit here was converted into this. So whichever you find easy for yourself to do. Okay. But it's still, yes, okay, if you look at it, the easiest would be as okay, meaning as okay to convert the bigger unit, expressing it worth using a smaller unit. That may be as okay that you multiply. Okay, but you have to still know as okay, how many micros are there in a milli? And vice versa. So know as okay, what to divide with, what to multiply with. So let's just say that we as okay went out with this conversion here and converted as okay our entire PRPs into yes okay microseconds, which we say as okay, that 10 microseconds that was going to be, or 10 milliseconds, sorry, is going to be as okay 10,000 microseconds. So now yes okay, both the units are going to be expressed, or both yes okay the times are going to be expressed using the same unit. So we says okay 10 microseconds. Now yes okay is okay divided by 10,000 microseconds. Multiplying by 100. Now we here mainly can say it's okay, this here is okay, we'll cut out this. And we actually is okay now end up with having 1 over 1,000. It's okay, multiply by 100. Now here's okay, the math is going to be that okay, 1 over 1,000. That actually is okay, will be the same as 0.001. Okay, now if you multiply that by 100, then your value or the result is going to be 0.1. But then you will have to just okay, write it as a percentage. Whereas if we did this multiplication here, so okay, what we got was 0.001. And that was your duty factor. So mainly as okay, to express it as a unitless, you don't really need to just okay, do the multiplication by 100. Did that make sense? Because once you multiply by 100, then you end up with okay, as what would be as okay, a percentage. Or percent. Or we say as okay, if 100% is 1. So in this instance here, it's okay, we mainly said, see, that okay, as this here is okay, that became our duty factor. Which mainly mean that okay, as 1,000th of the entire PRP was the on time. Did that make sense? We can do the same math and say it's okay, what if, or for instance, okay, what if for instance, okay, the PRP was greater, let's say it's okay, (20 microseconds). It's the same consideration that you have to do again and say, okay, either we convert the microseconds worth into milliseconds, or the milliseconds worth into microseconds. We can say, let's just say that we stick with this here. Okay. In that case, we can say it's okay, or equation made is okay, will be as okay. 20 microseconds was our on time. The entire PRP still was okay, as you can say it's okay, 10,000 microseconds. Clear? And since that's okay, still was a percentage, that's okay, we still need to write 100. But we can then say as okay, here, simple math, this cuts this. So we actually end with 2 divided by 1,000, which becomes, now we can make it okay, just simply do this math and say it's okay, that becomes 0.002. Or we could have said 2 divided by 1,000. That's okay, multiplied by 100. Now this would have become yes, okay, our duty factor. A unitless. Whereas if we do and multiply by 100, we can mean it says okay. These 2 zeros cuts out these 2 zeros, and it actually becomes 2 over 10, which is equal to 0.2. And then since we as okay did the math of the 100 is going to be as okay a percentage. So 0.22% or 0.22. Oh, sorry, 0.002, sorry. As a duty factor is the same as saying yes, okay, 0.2%. But meaning it's okay to get the unit factor, the duty factor as a unitless number. You don't really have to just okay do this multiplication by 100. Just simply divide the on time or pulse duration by your entire PRP. But make sure that okay, yes, that the units for those two are going to be the same. Clear? They may say, well, okay, your on time or your PRP is 10 milliseconds. And okay, say, well, okay, as your on time was 0.1 milliseconds. Then in this case, that's okay, you don't have to convert. Because this is milliseconds, this is millisecond. Then you just go and say, okay, 0.01 divided by 10. If you want to, it's okay, you can go and say multiply by 100. But as you know now, to get the duty factor as a unitless number, you don't really want to do this conversion here. Okay, so you can say it's okay, 0.01 divided by 10 is just going to be, it's okay, becomes 0.001. So that means that, okay, yes, 100% of your, or 100th of your entire okay on time was, the PRP was on time, which is going to become the duty factor. Okay. Any questions? Yes, I know that, but yeah.
Can we do another one?
Okay. Just give me the numbers. We practically as okay, just need 2 numbers. We need a PD. And we can say, okay, we need a PRF. No, PRP, sorry.
Yes, girls.
PD4.
Huh? What did you say, my dear?
Oh, sorry. 4.
4 horses, donkeys, cups of cake, what? My dear, your pulse duration needs a unit.
Microseconds.
Okay. Good. Then what is your PRP going to be?
Two microseconds.
Huh?
2
2 what?
microseconds.
It can't be. The
Hmm.
PRP has to be greater than the pulse duration.
Oh.
Oh, shit. If this is your PRP, and you say, yes, okay, that is 2 microseconds. And you make the pulse duration, it's okay, 4 microseconds is actually going to be twice this. It's not even going to be continuous, it's going to be continuously continuous. So it could be anything that is greater, it has to be greater than the pulse duration.
Milliseconds.
Okay. And you stick them with the 2, right?
Yeah, I can do that.
Yeah.
Okay. Yep, so we said, okay, yes, this was 2 milliseconds, and okay, as here we had, okay, as a pulse, which was 4 microseconds. Clear? So the duty factor is mainly going to be as, okay, how much of this entire PRP here is this. Now, since it was 2 different units, one thing that you have to make sure is that, okay, as both of them will be as, okay, expressed in the same unit. Clear? It's probably easier to say as, okay, let's just convert the worth of 2 milliseconds into microseconds. Which means that's okay, you multiply the number of milliseconds by 2, or by 1,000. Because each millisecond has 1,000 microseconds. So here's, okay, your equation, because it becomes just, okay, 2,000 microseconds. Now you have the same units. Now you can put the things into the equation. And say it, okay, as 4 divided by 2,000. And we can over here, it's okay, just say it's okay. You can say it's okay, multiply by 4. Now again, it's okay, you can just do the math and say it's okay. So it becomes 2
over 1,000. Which becomes, this math here becomes 0.002. That's your duty factor as being unitless. Did that make sense? Where you can say, okay, if you either multiply this whole thing here, by 100. You can still say, okay, these two here, okay, we've got this. And what do you have now? That becomes, okay, a 0.2. And then that has to be expressed as a percentage because you did this conversion here. So girls, there are some relationships that you will need to look into. Clear? What's the relationship of PRP and PRF? What are the relationship to PRF and depth, PRP and depth? What are the relationships to duty factor to PRP, PRF, depth, and vice versa? Clear? Now there are, some questions at the end of the chapter. And that will be your homework to do those. Okay. So I see you ladies tomorrow with chapter number 5. Tomorrow's Thursday, on a Friday is your quiz. So any questions that you have, we can take those up tomorrow. Okay. Take care. Stay blessed.
Thank you.
Yeah.